Hi everyone, in this video we'll introduce two identities. So in part 1 we're asked to show that sine squared theta plus cos squared theta is equal to 1. So recall that previously we saw that the definition of sine theta, so we know that sine theta is equal to y over r. We also know that cosine theta is equal to x over r. Now, we can replace, so we know that sine squared theta plus cos squared theta, we can write sine squared theta plus cos squared theta in terms of these ratios that we have. So this is equal to sine squared theta would be y over r squared, and cos squared theta would be x over r squared. And let's think about what this actually means. Well, remember that if we have, suppose that we have a circle, and it's drawn such that it's centered about the origin. Now that's not a very good circle, but let's just pretend that it is. And let's suppose that, so if I have an angle that's drawn in standard position, if this is the coordinate x comma y and this is r, then the sine of this angle theta is y over r. The cosine of this angle theta is x over r. This is just kind of to review what we've already looked at previously. So now I can go ahead and in this expression I've rewritten sine squared theta plus cos squared theta in terms of their ratios in this circle. So if we square this, we get y squared over r squared plus x squared over r squared. Now we have a common denominator, so we can just add the numerators, and we get x squared plus y squared over r squared. Here, if I look at this triangle that I have here, if this value is x and this is y, well, then I've got a right angle triangle where this dimension is the absolute, so this dimension here is the absolute value of x, this dimension here is the absolute value of y, and in this quadrant the absolute value of y is going to be the same as y, and the absolute value of x is going to be the same as x, but in the other quadrants that's not true. So that's why I have to say that a distance is always positive. So this distance here is the absolute value of x. So if I square x, though, that's the same thing as taking the absolute value, as squaring the absolute value. So I can think about this as the absolute value of x squared plus the absolute value of y squared. And of course, this is that is using the Pythagorean theorem. X squared plus y squared is equal to r squared. So I can replace x squared plus y squared with r squared. And what I'm left with is r squared over r squared, which is, of course, 1. Now, this identity here, the fact that sine squared theta plus cos squared theta is equal to 1, this is called the Pythagorean identity. So this is the Pythagorean identity. Let me write that down. Pythagorean identity. Okay, so next we're asked to show that tangent, and let me clear some space here. Oh, whoops. Okay, so let's clear some space on the canvas. For the next example, we're asked to show that tan theta is equal to sine theta over cos theta. So first note that tangent of theta, the tangent of theta, is equal to y over x. on that circle that I just erased. And sine of theta is equal to y over r, and the cosine of theta is equal to x over r. So I know that the sine theta over cos theta, well, if I replace sine theta with y over r, I have y over r, and I can replace cosine theta with x over r. So I've got y over r over x over r. Well, here I can simplify this. When you're dividing by a fraction, that's the same, or when you're dividing a number, that's the same thing as multiplication by its reciprocal. So I can change this from division to multiplication by the reciprocal of x over r, where I have y over r times r over x. And now that I'm multiplying, I can divide out some factors. So these factors divide out here, the factors of r. And what I'm left with is that this is equal to y over x, which is equal to tangent theta as required. So this gives us another identity. It gives us the this identity that tangent of theta is equal to sine theta over cosine theta. And something else to note is that that means that the cotan theta, because cotan theta is the reciprocal of tangent of theta, cotan theta is equal to cos theta over sine theta. So we're going to use these basic identities, the Pythagorean identity, and we're going to use these two identities to do what are called trigonometric proofs in future lessons. So let me just summarize what identities we have so far. We know that sine squared theta plus cos squared theta is equal to 1. This is one identity that we're going to use. We also know that tangent of theta is equal to sine theta divided by cosine theta. That's one that we just showed. And we know that cotan theta is equal to cos theta over sine theta. And we also we have our reciprocal identities where the cosecant of theta, just this kind of is review, the cosecant of theta is 1 over sine theta. The secant of theta is 1 over cos theta. And the cotan theta, or the cotan of theta, is equal to 1 over the tangent of theta, or 1 over tan theta. And we're going to look at how to apply these identities in the next lesson.